Hello everyone and welcome to another 3D Buzz training production. This is the Python Technical Directors course. It is for both member sponsors and will be produced as a series of training products available in the 3D Buzz store. Now, your lead instructor for this course will be Mr. Logan Frank. Logan is joining us now. How's it going, Logan?
Oh, it's going great.
All right. And myself, Jason Busby, will be playing the role as the lead student. Now, as many of you that have been through past 3D Buzz productions know, I don't always do a good job of being a student. And Logan's sitting in the corner right now kind of growling at me because he knows this as well. I will do my best of playing the role as a student and asking as many questions as I can think, but I do reserve the right to switch over to instructor mode if I feel it is necessary. And I would just like to insert some additional comments to what Logan is talking about. Now, for those of you that are trying to figure out why right now your screen is displaying only a dark shade of blue with the words Python Technical Directors Course and you're not seeing anything move around, that is because you are indeed looking at a static image that is being played back in video form right now. There should be nothing else moving. I would like to say this right now just before we have any students asking, where's the video? The video's there. There's nothing yet. So, this course is designed for technical directors. Okay, again, it is the Python Technical Directors course. If you've stumbled in this room by accident, leave now. All right, this course will have a specific focus on development for both Maya and Houdini. If you happen to work with another application that uses Python, you are more than welcome inside the Python classroom available on 3dbuzz.com to request, but odds are we're going to be sticking with Maya and Houdini, but we will see if we can make, exceptions if we happen to have that software and there's something that you request and it is capable, we are capable of demonstrating that without jumping too far off the path. But again, I'd just like to stress that we will be focusing our development on both extensions and tools for Maya and Houdini. Now, we will also be focusing on other applications of Python as well. We will be doing such things as mini games. We'll be looking at database integration, and we'll even be stretching things as far as to take a look at Python and OpenGL. These different applications of Python are considered important to both Logan and I for various reasons, and as you guys get a stronger and better understanding of the use of Python in the technical world, especially the 3D world that we're going to be focusing primarily on, you will see where these other applications become important for us as teaching tools. Okay? Now, what are the prerequisites for this course? Well, a basic understanding of programming is required. That is very important here for the simple fact that we are not going to do like we did in the XNA/C# class where we're going to break every single thing down for someone who's never touched a programming language before. Now, this does not mean that we're not going to focus on basic syntax. We're still going to talk about variables and declaration and how if statements work in Python, how loops work in Python, how to go about creating, our functions, our classes, how to instantiate classes. All of that stuff will be covered. But we're not going to spend a significant amount of time on the beginner type concepts. Okay, so we're going to say, all right, now let's take a look at how we would handle branching. We're going to cover if statements. We're going to jump in, we're going to talk about it, we're going to jump out, and then we'll start using it. Okay, so to wrap up the rest of this introduction, I'm just going to switch into student mode right now and just have a very basic conversation with Logan. Starting out, Logan, so what exactly is Python?
Well, really, Python is a general purpose programming language. And I say general purpose with the full intent of meaning that. There are many, many uses of Python. It really lends itself well to different applications.
Well, that's actually my next question then. So what's it used for?
Well, it's used for like I said, wide variety of things. These things can include standalone applications. Python can be used as a scripting language in conjunction with another system. It can be used for research, meaning that a small program used in scientific or mathematical research. It can be used to create games. It can even be used as a standalone calculator if you so wish. Some of the interactive functionality lends itself very well to that.
Okay. Now, obviously, in our case, with the primary focus being on both Houdini and Maya tool development, node development, etc., its power is really going to lie in the ability of enforcing our pipeline or allowing us to develop tools to speed production up in the 3D sense.
What's really interesting about Houdini and Maya specifically is, while Python has traditionally been used for just that, pipeline applications, where you use it as the glue language, where you write utilities, stick renders together, stick data together. It can, of course, it can still be used for that, but now its use is actually more double-edged. Python has been directly integrated into both the later versions of Maya and Houdini, meaning that in the case of Maya, you can actually use it to write plugins, which is a task that you once had to have C++ for.
Gotcha. Oh, that's very exciting. And we're going to get a look at these things, huh?
Oh yeah, that's directly where we're going. Like we're saying, this is for technical directors, meaning we're going to jump, well, very quickly into things like plugins, tool use inside of Houdini, and of course we can go even deeper into Houdini itself, since a lot of the Houdini architecture is actually moving over to Python.
Wow. Now, if I have a basic understanding of programming, because I heard that's the prerequisite for this course, so I do. Am I going to be okay getting into things like node development for Maya? Because obviously we're going to start getting into a lot of their language, a lot of things that are going to come from the API that's going to have to be familiar to me. I mean, are you going to teach these things?
I would say yes. I say you'll be just fine in those cases, because again, the only requirement is a basic understanding of programming. We mean know basically what an if is. Know that you have written a loop before, because when we get into these more complex architectures, we have to cover those generally. And really, it doesn't matter how good of a programmer you could be. You could be an absolute expert at Python. And if you open for example, the Maya API documentation for the first time, you're still going to have to learn things. It doesn't matter how well you know programming, you're still going to have to study these APIs.
Okay.
And that is precisely some of the things we're going to be covering as we delve deeper into these programs.
So you're saying I'm in good hands.
Yes, most certainly.
Okay, good. Now I'm feeling a little bit more relaxed. Let me move on to the next question I have for you. Since I know a little bit about programming, I can ask you this question with confidence. Is this a compiled or an interpreted language?
That's a bit of an interesting question, because at the end of the day, it can actually be both. It is possible that it can be both compiled and interpreted. It is...
Meaning I could have just an executable I could hand to somebody and they could run it?
That's right. Now, generally, it is interpreted. That is by far the most common use, is for the language to be interpreted. And by that, I mean it is generally executed by running a script file containing Python code, as opposed to running a binary executable.
Okay.
And then you simply let the installed Python runtime handle that script and do any necessary internal compilation.
Oh,
because compilation itself really can be looked at the fact that your typed lines of code end up getting compiled into an intermediate bytecode. But that gets into a discussion of virtual machines. What that generally means to you as the script writer is, in an interpreted sense, your script that you have written is, well, apparently it looks like it directly runs. Really what's happening is the installed runtime allows for execution. This is in contrast to the classic style of compilation, where the compiled output is a standalone application for your OS.
But there is a means that we could go about if we, for whatever reason, need to compile it to a standalone executable.
Yes, there are utilities available that will facilitate the packaging of the Python runtime together with your functionality, with your scripts, into one single executable. So if you wish to distribute a Python application in a way that doesn't require the end user to have Python installed, that is possible.
Okay. Well, that's very good to know. But in essence, we have a virtual machine.
Yes.
And it is executing bytecode. So
Right.
it's kind of similar to Java or the common language runtime with C#.
Exactly.
The whole .NET world.
And also for our purposes in this class, we will generally look at it as interpreted, because we're going to be working on scripts. We'll either directly run a script through the interpreter to see the output as we're researching the language itself, or we'll be giving those scripts off to Houdini or Maya or whatever the application may be, because those systems in turn will be running the Python runtime.
Now you say scripts. You know, when some people think of scripts, you know, they think of like PHP scripts or Perl scripts. I mean, can we build Windows and really complicated applications?
Oh, yes. And what I'm saying by scripts is I'm just using that as kind of a loose term for the code files themselves. I'm just saying script as one would say Perl script or any other kind of file that contains code that is to be executed by some other installed host.
Gotcha.
So when I say script, I just mean the code file.
But we can do complete user interfaces, etc., right?
And because of the interpreted nature, you can actually have a series of script files that actually, when put together, make up an application.
Very
but
nice.
yes, since the scripts that you write are standalone, really the only dependency for any given script is that you have the Python runtime. That means that your application could be a single script. that script could spawn the necessary windows, handle input, handle events as necessary to run like an application.
Are we going to be taking a look at some of that stuff as well?
We'll actually need to for some of the tools we're going to write, because we want to start investigating graphical tools, and that is going to involve having windows that will be usable by the user, and are actually trying to extend past the host applications themselves, meaning that these will be general application windows. So really, you can take some of this and use it beyond just the scope of inside of Max or Maya, or excuse me, Maya or Houdini.
Gotcha. Fantastic. Well, the next question I got for you, cross-platform. What operating systems will Python run on?
Well, it'll run on any operating system which is able to compile Python itself.
Also, the full source code for Python is available.
Oh yes, it's fully available. There's a special derivative of the open source license. It's, I believe, the Python software license. I could be wrong on the exact terminology, but there is a specific license under which Python is released. But it is open source in nature. That means you are free to obtain, download the Python source, and not only recompile it, but make adjustments as you see fit. So really, the final requirement is simply having a system which can compile Python. Though I would like to note that on many major systems, such as Linux, Windows, and Macintosh, there are pre-compiler, ready-to-use distributions available.
So most everybody will be able to just join right in.
Meaning that if, for example, if you're running on Windows, you don't have to delve into the source if you don't want to. There are installers available which will get you up and running quickly.
Awesome. Well, all right, so a funny question. Does it cost money?
No, Python itself is completely free. I guess going hand in hand with being open source, it is also free, which means that aside from any redistribution, I guess you could say redistribution conditions, just meaning that you can't hold onto the source or not re-release your changes.
Gotcha.
But yes, Python itself is completely free, both in source form and in installer form. So that means for pretty much any level of application, even if you're running on a commercial level and you're using this in the development of maybe a film or even a completely new software application you intend to sell as you redistribute, all of those are open. It's it's free to use as long as you fall within the license or the way the license works. And really, that's just so you don't steal the code, run off, and don't show anyone what changes you made.
Gotcha. All right, object orientation. So it's object oriented. It supports encapsulation, inheritance, polymorphism, all those.
Technically, Python is actually a multi-paradigm language, simply meaning that it doesn't force a specific structure on you. You're free to program in a purely procedural manner if you wish, but object orientation is also supported. It is a supported paradigm within Python. That means you have concepts like encapsulation, inheritance, polymorphism. As a matter of fact, a lot of the built-in types in Python are themselves classes.
Gotcha.
So yes, you have full support of the concept of a class, and you have a lot of the, or you have object-oriented abilities with those.
Okay.
So you can build your Python applications in a fully object-oriented sense.
So I'm just going to kind of peek over your shoulder here. So some of the lessons coming up, I mean, obviously we need to do an introduction here, but after this, what we got planned? Getting it installed, we're going to get things up and running?
Yes, we're going to give an example follow-through of the installation, just so if anyone's watching, they can follow step-by-step to get up and running.
Okay.
Since we're running on the Windows platform, we will, of course, just be using the Windows installer. So we're going to take a rather simplistic route to get this installed, up and running, and that'll take care of that lesson.
Then we'll move into command line interpreter, some, good old hello world type stuff.
Well, right. After we get everything installed, we do, of course, want to make sure that, one, the installation is working, and then just poke at the language very briefly. We'll write the classic hello world app, which in Python consists of one line. But we'll also take a look at the interactive interpreter as we do this.
All right, cool. And then from there, we're just going to slowly start getting deeper and deeper into Python itself.
Exactly. We'll move into one of the built-in IDEs, take a look at using that as a tool to help us as we're learning Python.
All right, outstanding. Well, Logan, to be honest with you, I'm very excited and look forward to pushing our way through this course. I hope our students are as excited as well, or are excited as well, excuse me. And with that, that is going to wrap up this introduction to the Python Technical Directors course. Thanks a lot.